You see a dot moving through this darkness. Just one telescope in Chile catches it on July 1st, 2025. Nothing special at first glance, but within 24 hours, astronomers know they have something impossible. This object is moving at 137,000 miles per hour. Too fast to belong here. Too fast to orbit our sun. It came from another star. 3I Atlas is only the third confirmed visitor from beyond our solar system. The first was Oumuamua in 2017. The second was 2I Borisov in 2019. Both left more questions than answers. But 3I Atlas is different, bigger, brighter, more active, and carrying chemistry that breaks every rule we know about natural objects in space. If you value documented Viking and Norse era history like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual. Using sources from the European Southern Observatory's Very Large Telescope X-Shooter Spectroscopic Survey, published by Rohan Rahatgaonkar and colleagues in August 2025, and NASA's James Webb Space Telescope NIR spec observations, published in the Archive, preprint 2508.18209 by Martin Cordner's team at Catholic University of America. Now, back to the information. The Atlas Survey Telescope at Rio Hurtado spotted 3I Atlas at 4.5 astronomical units from the Sun. That's 4.5 times farther than Earth. At that distance, comets should be frozen solid, dead. But 3I Atlas was already active, already glowing, already defying physics. Hubble Space Telescope locked onto the target on July 21st. The image showed something astronomers had never seen before. Instead of a tail pointing away from the sun like every normal comet, 3I Atlas had an anti-tail, light scattered toward the sun, not away from it. David Jewett at UCLA called it unprecedented. 27 August 2025. Gemini South Telescope in Chile captures the first clear view of 3I Atlas, developing a proper tail. The Coma now spans 120 degrees in the sky. 56,000 kilometers of glowing gas and dust, but this is where the story gets strange. James Webb Space Telescope trained its infrared eye on 3I Atlas on August 6th. What it found rewrote the chemistry of interstellar objects. The Coma contained carbon dioxide, lots of it. 8 parts carbon dioxide to 1 part water. The highest ratio ever measured in any comet. Martin Cordner at Catholic University of America led the observations. His team found carbon dioxide dominated 95% of the gas by mass. Water made up only 5%. No comet in our solar system behaves this way. Water ice is the foundation of every comet we know. It drives their activity, creates their tails. But 3I Atlas runs on carbon dioxide instead. Dry ice, the kind that sublimates directly from solid to gas without melting. SphereX Space Observatory confirmed Webb's findings between August 7th and 15th. The carbon dioxide cloud around 3I Atlas extends 348,000 kilometers into space, nearly the distance from Earth to the Moon. All carbon dioxide, no water. No carbon monoxide, just pure carbon dioxide fog wrapping an object from another star. But carbon dioxide was only the beginning. Very Large Telescope in Chile started tracking 3I Atlas with its X-Shooter spectrograph on July 4th. What happened next shattered 40 years of comet science. The telescope detected atomic nickel vapor streaming from 3I Atlas. Nickel emission isn't unusual. Many comets emit nickel as solar heating breaks down metal-bearing grains, but 3I Atlas emitted nickel without iron. Not a trace of iron anywhere. In 4 decades of studying comets, no astronomer had ever seen nickel without iron. Nickel and iron are cosmic twins, born together in the nuclear fires of supernova explosions, found together in every asteroid, every meteorite, every grain of space dust ever analyzed. Their separation is impossible in nature. Rohan Rahatgaonkar led the Very Large Telescope team. His measurements showed 3I Atlas, pumping out 4.6 grams of nickel per second by August 21st. The production rate exploded as the comet approached the Sun. Following a power law with an index of minus 8.43, nothing natural exhibits this pattern. August 22nd brought another discovery, cyanide gas. 3I Atlas was bleeding cyanide at 17.6 grams per second. The production rate climbed even steeper than nickel. Power law index of minus 9.38. Thomas Puzia at Pontifical Catholic University of Chile analyzed the data. He called it cracking open the door to a whole new world of chemistry. Nickel without iron, industrial levels of cyanide, carbon dioxide dominating water by 8 to 1. These signatures point to chemistry unknown in natural space objects. On Earth, nickel without iron appears in industrial refining of nickel alloys. Nickel cyanide coatings protect metals from corrosion. But this is space, billions of miles from the nearest factory. The expanding coma of 3 I Atlas tells a story written in molecules. As the object approaches the sun, solar heating drives sublimation. Carbon dioxide ice turns directly to gas. The gas carries fine dust grains less than 1 micrometer across. These particles scatter sunlight, creating the visible coma, but the chemistry is wrong. The ratios are wrong. The behavior is wrong. Stephanie Milam at NASA Goddard proposed one explanation. 3 I Atlas spent billions of years drifting through interstellar space. Cosmic rays bombarded its surface. High-energy particles could cook the outer layers, create exotic ices, transform normal comet chemistry into something unrecognizable, a cooked shell of processed materials wrapping an ancient core. But the cooked shell theory doesn't explain nickel without iron. Cosmic ray processing would affect both metals equally. Something else must be separating them. Something that breaks the fundamental rules of space chemistry. David Jewett at UCLA measured the nucleus size using Hubble data between 440 meters and 5.6 kilometers across. Small for such a bright object. The brightness comes from the expanding coma. Gases and dust reflecting sunlight across hundreds of thousands of kilometers. But where's the tail? Normal comets develop prominent dust tails when solar radiation pressure pushes particles away from the nucleus. 3 I Atlas shows no such tail in Hubble images. The scattered light extends in all directions equally, like a sphere instead of a teardrop. Another violation of comet physics. September 7th, 2025. Michael Yeager and Gerald Raymond capture new images showing 3 I Atlas changing color. The object that appeared reddish in all previous observations now glows green-blue. The color shift coincides with the explosive increase in cyanide production detected by a Very Large Telescope. Cyanide molecules emit characteristic green light when energized by solar ultraviolet radiation. The timing matters. 3 I Atlas passed closest to Mars on October 3rd. NASA's Mars Reconnaissance Orbiter photographed the object at 30-kilometer resolution. These images will reveal whether the brightness comes from a giant nucleus or an extended dust cloud. Either answer creates problems for our understanding of interstellar objects. 3 I Atlas reaches perihelion on October 29th, 2025, 1.36 astronomical units from the Sun, just inside Mars orbit. Close enough for maximum solar heating. Close enough to drive off the remaining volatiles. Close enough to reveal what lies beneath the expanding coma, but the window is closing. After perihelion, 3 I Atlas speeds away on its hyperbolic trajectory, back into the void between stars. Back to wherever it came from billions of years ago. This is humanity's only chance to study an active interstellar comet up close. November brings one last opportunity. When 3 I Atlas emerges from behind the sun, Bryce Bolin at Eureka Scientific will host another observing session with Gemini North Telescope. Students and scientists working together to capture the final images of our mysterious visitor, to measure what's left after the sun strips away its outer layers. The expanding coma reveals 3 I Atlas as something unprecedented. Not quite a normal comet, not quite an asteroid, something between, something carrying chemistry from another star system, chemistry that challenges our understanding of how planets form around distant suns. 8.0 plus or minus 1.0. That's the carbon dioxide to water ratio measured by James Webb Space Telescope. 4.4 sigma above the trend for known comets. A statistical impossibility if 3 I Atlas formed like objects in our solar system. It came from somewhere different, somewhere carbon dioxide ice could dominate over water ice. The carbon dioxide ice line. That's where Martin Cordner's team thinks 3 I Atlas formed, far from its parent star, in the cold outer regions where carbon dioxide freezes before water. A zone that barely exists in our solar system but might be common around other stars. Stars with different masses, different luminosities, different planetary system architectures. 3 I Atlas carries pristine materials from the epoch of galaxy formation. Potentially 3 to 11 billion years old, older than our entire solar system, older than Earth. A messenger from a time when the galaxy had different chemical abundances, different stellar populations, different conditions for planetary system formation. The nickel production rate increases with the power of 8.43 as 3 as I Atlas approaches the sun. No known physical process produces this steep dependence. Natural sublimation follows gentler curves. Thermal desorption exhibits different patterns. Something else is driving the metal emission from 3 I Atlas nickel tetracarbonyl. That's Thomas Puzia's hypothesis, a volatile organometallic compound that breaks apart easily under solar ultraviolet light, releasing pure nickel atoms and carbon monoxide gas. The compound exists in industrial chemistry, forms during certain metallurgical processes. But how did it get into an interstellar comet? The Very Large Telescope detected no iron emission lines anywhere in 3I Atlas's spectrum. Iron should be there. Must be there if this is a normal space object. Its absence suggests either exotic chemistry or instrumental limitations. Future observations with James Webb. Space Telescope might detect iron at infrared wavelengths invisible to ground-based telescopes, or confirm that 3I Atlas really does violate the iron-nickel correlation that defines natural space objects. Radio silence. That's what David Gross at UC Santa Barbara recommended. Listen for technological signals from 3I Atlas. Monitor radio frequencies for any sign of artificial origin. The suggestion sparked debate among astronomers. Some called it premature. Others noted the unprecedented chemistry, the impossibly steep emission curves, the violation of fundamental space physics. Avi Loeb at Harvard pointed out troubling coincidences. 3I Atlas follows a trajectory aligned with the ecliptic plane of our solar system. The statistical probability is 1/5 of 1%. It arrives 80 years after humanity began broadcasting radio signals, 80 years after the first nuclear test, as if something noticed our technological awakening and decided to investigate. But the evidence points both ways. 3I Atlas exhibits clear cometary activity, sublimating ices, expanding coma, developing tail, all the signatures of a natural object heated by solar radiation, yet the chemistry remains impossible. The metal emissions defy physics. The carbon dioxide dominance breaks comet rules. September 4th, 2025. 3. I-Atlas passed NASA's Psyche spacecraft en route to the metal-rich asteroid Psyche. Close enough for observation, close enough for detailed measurement, but Psyche's instruments aren't designed for comet analysis. The opportunity slipped away. October brings the critical test. Multiple spacecraft positioned throughout the inner solar system will observe 3I Atlas during its closest approach to the Sun. Hubble Space Telescope, James Webb, Space Telescope, TESS, SWIFT, Mars Reconnaissance Orbiter, Curiosity Rover, Perseverance Rover, Europa Clipper, JUICE, Parker Solar Probe, a coordinated campaign to solve the mystery of our most enigmatic interstellar visitor. The expanding coma grows larger as 3I Atlas approaches perihelion. More gas, more dust, more exotic chemistry. The carbon dioxide fog now spans nearly 500,000 kilometers, larger than the distance between Earth and Moon, all driven by dry ice sublimation instead of normal water ice processes. Water ice exists in the coma. James Webb detected it as fine crystalline grains smaller than 1 micrometer. But these particles sublimate far from the nucleus, 4,000 to 10,000 kilometers away, ejected by carbon dioxide outgassing rather than their own sublimation. Another inversion of normal comet behavior. The mystery deepens with each observation. 3. I-Atlas defies classification, too active for an asteroid, too chemically strange for a normal comet, too old for most formation scenarios, too fast for solar system origin. It occupies a category of 1. Interstellar objects like 3I Atlas offer our only direct samples of material from other star systems. Chemical messengers carrying information about planetary formation around distant suns, about stellar evolution in different galactic environments, about the diversity of worlds beyond our cosmic neighborhood. But 3I Atlas refuses to fit our models. Its chemistry suggests formation in conditions unlike anything in our solar system, perhaps around a carbon-rich star, perhaps in a system with unusual ice line locations, perhaps through processes we don't understand. The Very Large Telescope observations ended on August 21st, as 3I Atlas approached the Sun too closely for nighttime viewing from Chile. The final measurements showed nickel production exceeding 22.67 on the logarithmic scale, nearly 4 grams per second of pure metal vapor streaming into space, cyanide emission climbing even faster. These production rates place 3I Atlas among the most active objects ever observed, more active than many comets much closer to the Sun. Driven by volatile ices that shouldn't exist in such quantities, following power laws that describe no natural process. November will bring the final chapter. When 3I Atlas emerges from solar conjunction, astronomers expect dramatic changes. Most of the carbon dioxide should be gone. Water ice might take over as the primary volatile. The chemical signature could shift toward normal comet behavior, or reveal new impossibilities. Karen Meach at University of Hawaii leads the International Observation Campaign. Her team used public outreach sessions to engage students during critical observations. Science in real time. Discovery shared as it happens. The next generation of astronomers learning about interstellar chemistry from the most enigmatic object in the solar system. The expanding Coma of 3I Atlas tells us that interstellar space contains objects unlike anything in our solar system, chemistry forged in different stellar environments, physics operating under different conditions, processes that challenge our understanding of how planetary systems form and evolve. But it also tells us something else, something written in the steep power laws of metal emission, in the impossible separation of nickel and iron, in the carbon dioxide fog that defies comet physics. 3. I-Atlas might be the most important object to enter our solar system in human history. October 29th, 2025, marks perihelion. 3 I-Atlas reaches its closest approach to the Sun at 126 million miles, the moment of maximum heating, maximum activity, maximum revelation. After this point, our interstellar visitor begins its journey back to the void, back to the darkness between stars, back to wherever it came from billions of years ago. The expanding Coma will eventually dissipate. The exotic chemistry will fade as volatile materials are stripped away by solar radiation. The mystery will remain. Did we witness the death of an ancient comet from another star? Or did we glimpse something else entirely? Something that challenges our assumptions about what exists in the universe beyond our small corner of the galaxy. Ground-based observations from Chile's Atacama Desert captured 3. I-Atlas, transitioning from red to green-blue as cyanide production exploded in early September. The color change visible to amateur astronomers worldwide. An interstellar object transforming before our eyes, revealing chemistry written in light across the electromagnetic spectrum. The final measurements will come from space-based telescopes immune to atmospheric interference. James Webb Space Telescope can detect molecular signatures invisible to ground-based instruments. Hubble can resolve structural details smaller than any terrestrial telescope. Together, they might solve the puzzle of 3I Atlas before it disappears forever, or they might deepen the mystery. Add new impossibilities to an already impossible object. Force us to expand our understanding of what's possible in the universe. Challenge our assumptions about the chemistry of interstellar space, about the diversity of objects drifting between the stars, about what might be out there waiting to be discovered. The expanding Coma of 3I Atlas carries messages written in molecular handwriting, carbon dioxide instead of water, nickel without iron, cyanide at industrial levels. Chemistry that points to formation conditions unlike anything in our solar system, to stellar environments we can barely imagine, to processes that operate on scales of space and time beyond human experience. But the message is clear: we are not alone in the universe, not alone in our solar system. Visitors arrive from other stars, carrying stories of distant worlds, chemical signatures of alien environments, physical evidence that planetary formation operates differently around different suns in different regions of our galaxy. 3 I-Atlas represents the third confirmed interstellar object detected by human civilization, the largest, the brightest, the most chemically active, and potentially the most important for understanding our place in the cosmic community. A messenger from deep space carrying news from a realm we can visit only through the objects that visit us. The expanding Coma grows larger each day as 3 I-Atlas approaches the Sun, fed by sublimating dry ice, energized by solar radiation, revealing chemistry one molecule at a time. Each spectroscopic line tells part of the story. Each emission feature adds another piece to the puzzle of our enigmatic visitor. December brings the final observations before 3 I-Atlas speeds away forever, the last chance to study an active interstellar comet, to measure what remains after the Sun strips away its outer layers, to glimpse the ancient materials hidden beneath billions of years of cosmic weathering. After that, silence. 3 I-Atlas will fade from view as it retreats toward the edge of the solar system. Its hyperbolic trajectory will carry it back to interstellar space at 58 kilometers per second, faster than any human-made object, faster than escape velocity from our entire solar system. But the data remains, the measurements endure, the mystery persists. What exactly did we observe during those crucial months of 2025? Was 3I Atlas a natural comet with exotic chemistry, an ancient artifact from the early universe, or something else entirely? The answer may reshape our understanding of interstellar space, of planetary formation around other stars, of the chemical diversity possible in cosmic environments, of what awaits discovery in the vast darkness between stellar systems. 3 I-Atlas entered our solar system carrying secrets from another star. It leaves behind more questions than answers, but also knowledge. chemical fingerprints of an alien world, physical evidence that the universe contains objects beyond our current classification schemes, proof that the cosmos still holds surprises for species brave enough to look up and wonder what's out there in the dark.